In this video, we're going to talk about Fermat Factorization. Fermat Factorization is useful for factoring some large, odd composite numbers. We don't use it for even numbers, as an even composite number can be factored by continually dividing by 2 until you reach a point where you can more easily break it down by other methods, or, if your remaining number is still large, apply Fermat factorization at that point. However, we don't begin the process of Fermat factorization with an even number. Here's how Fermat factorization works. Suppose we wish to factor some composite number n. Our strategy is to identify some number s such that the square root of s squared minus n results in a whole number. In other words, we are trying to find s squared minus n that happens to be a perfect square. But how do we decide which values of s to use? We determine a starting point for values of s by taking the square root of n. Let's look at a specific example. Suppose I have the number 426,749, and I want to factor this number. I begin by taking the square root of our n, 426,749. The square root of this number is about 653.26. So my first value of s will be 654. In other words, we determine our starting point of s by taking the square root of n and rounding up to the nearest whole number. So the square root of s squared minus n will be the square root of 654 squared minus 426,749. This gives us a value of approximately 31.1. So we know that in this case, s squared minus n is not a perfect square. Let's try another value of s. Let's try 655. So the square root of 655 squared minus 426,749 is approximately 47.7. Again, s squared minus n is not a perfect square. Let's try 656. Here, the square root of 656 squared minus 426,749 is equal to approximately 59.9. That won't work, so let's try again with 657 as our new s. Now we have the square root of 657 squared minus 426,749, and this gives us an answer of 70. So now we have found that 657 squared minus 426,749 is a perfect square. We need to use this information to help us find the factors of our original value of n. It's fairly straightforward. We set up parentheses, plus sign in one, minus in the other. The first is 657 plus 70, and the second factor is 657 minus 70. Simplifying, we have 727 times 587. And if you multiply these numbers together, you'll see that you get your original value of n, 426,749. This concludes our example of Fermat factorization. I hope you found it helpful, and we'll see you next time.